Hey guys, welcome to this free lesson on solving applications of quadratic equations. I'm going to go through just a few quick examples for you, and so I highly recommend that you pause and try the examples when you are prompted, and there are always free guided notes available, which might be really helpful in this lesson. Also, if you find my channel helpful, please consider liking this video or subscribing and sharing my channel or leaving me a comment. Just any feedback helps me decide kind of what to do next with this channel. So let's get started. So I really just have like a couple of examples here to go through. So the first one is having to do with quadratics and projectiles. And projectiles always come up with quadratics. They're like a favorite thing to kind of do. So this says an object is thrown upwards off a cliff that is 48 feet above the ground. The height of the object t seconds after the object is released is given by this equation h equals negative 16t squared plus 32t plus 48. And the question is, how long does it take the object to hit the ground? Okay, so just to like kind of take a second to talk about this, this equation does not come out of thin air. I feel like a lot of times we think that stuff like this just comes out of nowhere. But this is actually a very interesting application of physics. And if you were to take a physics class, you could totally just learn about one of these applications. So this negative 16 actually has to do with the coefficient for gravity. So this is not just a made up number. This actually is how this is the coefficient of how gravity always pulls everything back down to the earth. So if you ever take a physics class, just something for that. And then the 48 is exactly what this number is here. So you can kind of understand how this equation gets created. So t is talking about the time that this object is in the air, and h is talking about how high the object is above the ground. So if I ask how long does it take to hit the ground, what does the ground mean in terms of height in this context? Well, this would mean then that height would equal 0. So what I need to do is just set this equation then equal to 0. So this will be negative 16t squared plus 32t plus 48 equals 0. So this is what you need to solve. So now what you might want to do is just pause the video, hit play when you're ready, and see if you can figure out how to do that. Okay, so the first thing to notice with this is that you can factor out 16. So if you do that, this becomes t squared minus, so I'm factoring out negative 16, so I have to flip all my signs, right? So this becomes minus 2t minus 3 equals 0. And so then I can factor this as t minus 3 and t plus 1. So I get either t equals 3 or t equals negative 1. Now, usually when we do this in math, those solutions are fine, but now we're actually dealing with an application here, right? So now you have to think about, what does this actually stand for? So t, we said, stands for seconds, right? That's discussed up here. So which one of these makes sense? The one that's positive, right? So sometimes when you're doing these, you have to discard solutions. So it takes 3 seconds to hit the ground. So now I just want to make a slight tweak to this problem. Instead of asking how long does it take the object to hit the ground, now I'm going to say how long does it take the object to reach a height of 20 feet. And so how does this change the problem? What does this mean that I need to do? Well, now it's explicitly telling me I need to set my height equal to 20. So if I restate this problem, negative 16t squared plus 32t plus 48 equals 20, now this really changes everything, actually, because you can't just go and factor this unless this side equals 0. So the first thing you've got to do then is make this equal 0, so we have to subtract off the 20. And so now I've got negative 16t squared plus 32t plus 28 equals 0. Now, this is kind of a problem because 16 doesn't just factor out of all of these, right? So this will change our approach. Instead, what number could be factored out? Maybe you want to pause the video and think about it for a second. Well, I can factor out negative 4. And if I do that, so what is this going to become? This is going to become 4t squared minus 8t minus 7. And now that I have factored that out, well, the news here is that this cannot be factored, right? So this makes the problem significantly harder, actually. And so what we're going to have to do then is we're going to have to think of another way to factor just the part in here. We can actually just focus on this and keep it a little bit simpler. So let me clear off some space. And I guess the best thing for us to use, I mean, as you're thinking through it, factoring is not going to work. Using completing the square wouldn't be great because you have to divide everything by 4, and unfortunately this can't be divided by 4, the 7. So probably really your best bet's going to be the good old quadratic formula. So what I have to do then is I have to set my a equal to 4, my b equal to -8, and my c equal to -7. So now I just got to plug that in. So I've got t equals, and so I'll write this all out. Okay, and so there's everything plugged into my quadratic formula. And notice, so this should be -b², so this would be -8, so I just wrote +8 here. So now let me use the order of operations to start simplifying this. And so now what I'm going to have to do is see, now that I've taken it to this point, just you have to think, can you simplify this square root any farther? And you can. 16 will actually divide into this. So 16 divides into this, so this will actually become plus or minus 4 times the square root of 11, all of this divided by 8. And I'm running out of space here. Let me clear myself a little space up here, and I'll move the problem up. And so if I break this into pieces, so this will be t equals 1 plus or minus 1/2 times the square root of 8. And so that's as far as I can go with that. Now, you might have to get out a calculator to actually help you with this, to figure out what is this as a decimal. And if you use something like a calculator to kind of help you figure this out, so 1 minus 1/2 times the square root of 8, this actually will end up being something negative, so that won't work for time. So the only one that will work is 1 plus 1/2 times the square root of 8, and that equals about 2.14 seconds. So, you know, you're not always going to get, with a real world application, some beautiful rounded answer, right? Sometimes you will get these decimals, and so that's common. So sometimes you have to kind of think through that. So now I have one last problem for us to talk about, a little bit different than the previous one. So a 12 by 16 foot pond is going to be surrounded by a border of grass of uniform width all the way around. If the area of the grass must be 480 feet squared, what is the width of the grass border? Okay, so let's draw a picture of this. So I have a pond, so there's my pond, and so this is 12, 12, 16, 16, just to be nice and clear. And it has this grass border around it of uniform width. So I don't know what the width is, right? So what should I call that? I'll call this X, right? That's usually what we call it. We know it's all the same width, so we can label all of them as X. But the one thing I know about this is that the grass itself, this green part in here, kind of going through here, this has to be 480 feet squared. So what is the width of this border then? Well, to figure this out, right, we probably need to know what is really the width of all of this. So if I think about what is just this length here, what would this length be? Well, we know that this here is 12, and then this is 12 plus x plus x. So this would just be 12 plus 2x. And then if I go the other direction, so if I go from here to here, so this is going to be x plus 16 plus x. So that's 16 plus 2x. So I can get the area of the whole thing, right? So that would be 16 plus 2x times 12 plus 2x. But the problem with this, I don't want to set this just equal to 480, right? Because that's not what this represents. This says the area of the grass must be 480. So now I want to figure out, how do I isolate just the green part? Well, to do that, I'll erase this for a moment, I have to then subtract off the actual area of the pond, which we do know, right? So I can find the area of the pond by just doing 16 times 12. And if I subtract that off, then I will be good to go. So now we can work this out. So let's see. 16 times 12 is 192, and then this will be plus 24x plus 32x plus 4x squared minus 192, and that's all going to equal 480. So now if I collect my terms and whatnot, I get 4x squared plus 56x equals 480. Okay, so let me clear myself a little bit of space and make sure you've written this all down before I clear it. Okay, so just to have a little more room, I'll put the problem up here. So now this is quadratic. I can see this is going to be a quadratic equation, so I need to set this whole thing equal to 0. So I need to subtract off the 480. So I get 4x squared plus 56x minus 480. And so now I would certainly like to factor this if possible. So what I'm going to do is, it looks like I can factor out a 4 from this. There's a GCF. So let's see, this will equal 14x minus 120. Okay, equals 0. All right, so that is how that is going to factor. Now, it might take you a little bit of trial and error to figure this out. So maybe you want to hit play when you've had a moment to try factoring this. But this will factor as x plus 20 and x minus 6. So I get x equals negative 20 or x equals 6. So what must the width of the border actually be? Well, obviously the border can't be negative, so it must be 6 feet. So the border is 6 feet around. And so that would be how you would approach something like that. And so that will cover everything in this video. So thanks for watching, and I will see you guys next time.